a telescope floating silently above Earth for over 34 years, peering into the cosmos, capturing moments that rewrite what we think we know about our universe. That's the Hubble Space Telescope. Not just a window to distant galaxies, but a sharp-head explorer of our own solar system, revealing secrets from our closest neighbors to the farthest planets. It wasn't built to focus on our cosmic backyard, yet it's caught extraordinary events that would have slipped by unnoticed. Let's embark on a journey through the solar system guided by Hubble's lens to uncover stories of planets, moons, asteroids, and collisions that spark wonder and curiosity. Our journey starts close to home with the Moon. You'd think a telescope as powerful as Hubble could snap a perfect portrait of our lunar neighbor, but its surface is just too big and bright to fit in one frame. Other missions, like NASA's Lunar Reconnaissance Orbiter, take sharper lunar shots. But in 2012, Hubble found a clever way to steal the spotlight. During a rare event, Venus passing in front of the Sun, scientists used the Moon as a giant mirror. They bounced sunlight off its surface to study how it filtered through Venus's thick, hazy atmosphere by catching subtle changes in that light. Hubble revealed clues about the chemicals swirling in Venus's skies. It was like using the Moon as a cosmic reflector to decode another planet's secrets. This trick wasn't just a one-off. It's a technique Hubble uses to study far-off exoplanets peering at distant stars as planets cross their path. The Sun's too bright for Hubble to stare at directly. But with the Moon's help, it pulled off a brilliant workaround, proving its ingenuity, even in our own neighborhood. Moving outward, we land on Mars, the red planet that's long captured our imagination. Unlike spacecraft orbiting Mars, which see only patches of its surface, Hubble gets the full view, a global portrait of a world shaped by wild weather. It snapped images of towering dust storms that can swallow the planet whole, turning its rusty surface into a hazy blur. One stunning time-lapse captured a global dust storm in action, engulfing Mars and hiding its craters and mountains entirely. These images aren't just pretty pictures. They help scientists predict Martian weather, plan rover missions, and understand seasonal shifts. Hubble's also caught Mars' tiny moons, Phobos and Deimos, zipping around the planet. Phobos, the larger of the two, is a speed demon orbiting Mars in just 7.5 hours, faster than any other moon in our solar system. In one 22-minute time-lapse, Hubble showed Phobos racing across the Martian sky, a fleeting shadow against the red backdrop. These glimpses remind us that even familiar planets hold dynamic stories, and Hubble's there to catch them. Now, let's venture into the asteroid belt, a chaotic stretch between Mars and Jupiter, teeming with millions of rocky fragments. Here, Hubble's revealed objects that defy expectations. Take 6478 Gault spotted in 2019. At first glance, it looked like a comet, sporting not one but two tails streaming behind it. But this wasn't a comet. It was an asteroid spinning so fast it was tearing itself apart. Every 2 hours, this 3.5 kilometers wide rock completes a full rotation pushed to its limits by something called the Yarkovsky effect. That's when sunlight nudges an asteroid, speeding up its spin over time. For Gault, this rapid twirl creates centrifugal forces stronger than its own gravity, flinging loose material into space to form those comet-like tails. Scientists say Gault might not hold together much longer. It could disintegrate entirely, a reminder that asteroids aren't always solid rocks, but fragile piles of rubble barely clinging together. The asteroid belt is a cosmic junkyard with 1 to 2 million objects larger than a kilometer and countless smaller ones all tumbling in a delicate dance of chaos. Then there's P/2010A2, another asteroid belt oddity that fooled astronomers at first. When Hubble zoomed in, it saw what looked like a comet's nucleus with a strange X-shaped structure nearby. But this wasn't a comet either. It was the aftermath of a cosmic fender bender, a collision between two asteroids. The X-shape came from debris blasted in 4 directions, some pulled back by the faint gravity of the wreckage, some escaping into space. This was a rare glimpse of the asteroid belt's violent side, where collisions shape the fates of these ancient rocks. Most asteroids stick to stable orbits, but stray too far, and they might meet a bigger player like Jupiter, the solar system's heavyweight champion. Jupiter, with nearly 34% of the solar system's mass outside the Sun, is a force to be reckoned with. Its gravity can shred comets and redirect asteroids, acting like a cosmic vacuum cleaner. In 1994, Hubble gave us a front-row seat to one of the most dramatic events ever witnessed, the collision of comet Shoemaker-Levy 9 with Jupiter. This comet, captured by Jupiter's gravity decades earlier, got too close and was torn into fragments. When those pieces slammed into the gas giant at 60 kilometers per second, over 210,000 kilometers per hour, they unleashed chaos. Fireballs hotter than 23,000 Kelvin soared 3,000 kilometers above Jupiter's clouds. The biggest impact left a dark scar 12,000 kilometers wide, about the size of Earth, with energy equal to 6 million megatons of TNT, 600 times the power of all the world's nuclear weapons combined. This was the first time we'd seen a collision on another world, and it backed up the idea that Jupiter's massive gravity shields inner planets like Earth from catastrophic impacts. But Jupiter is not just a protector, it's a spectacle. Its auroras, unlike Earth's fleeting northern lights, glow constantly, hundreds of times brighter. In 2016, as the Juno spacecraft headed to Jupiter, Hubble watched these auroras daily for months. It found they're powered not just by solar wind, but by Jupiter's intense radiation belts and magnetic fields, creating a light show unlike anything else in the solar system. Jupiter's moon Europa steals the spotlight next. This icy world is a top candidate for hosting alien life with a vast ocean hidden beneath its frozen crust. Jupiter's tidal forces heat Europa's interior, keeping that ocean liquid. While spacecraft like Voyager and Galileo took stunning close-ups, Hubble brought something unique, the ability to see in ultraviolet light. It spotted what looked like W. Even more exciting, Hubble found sodium chloride, table salt, in Europa's ice, hinting that its ocean might be chemically similar to Earth's. These discoveries make Europa a prime target for future missions hunting for signs of life. Beyond Jupiter, we reach Saturn, the ringed giant. Since the Cassini mission ended in 2017, Hubble has been our best tool for watching Saturn's massive storms, some stretching thousands of kilometers. Its images keep us connected to this distant world, tracking changes no other telescope can see. Further out, Uranus and Neptune, visited only once by Voyager 2 in the 1980s, remain mysterious. Hubble's filled the gap, capturing seasonal shifts in Uranus's pale blue atmosphere and even discovering Neptune's tiniest moon, Hippocamp. Without Hubble, this small moon might still be hiding in the shadows. These observations refine our understanding of how our solar system formed, piecing together clues from worlds we rarely visit. Hubble's been at it for over 3 decades, far outlasting its planned lifespan. With care, it could keep going until 2040, maybe even outshining its successor, the James Webb Space Telescope. It's given us more than images. It's given us stories. From Venus's atmosphere to Mars' storms, from spinning asteroids to Jupiter's fireballs, from Europa's salty seas to Neptune's hidden moons, Hubble's shown us our solar system is alive with surprises. Each discovery reminds us that the universe is vast, chaotic, and full of wonders waiting to be explored. So, let's keep looking up, because Hubble's still out there, capturing the next chapter of our cosmic story. Let's circle back to the asteroid belt for one more tale because it's too wild to skip. Remember P/2010A2? That X-shaped debris cloud wasn't just a snapshot. It was a window into the asteroid belt's restless nature. The collision that created it scattered rubble in 4 directions, some drifting back to the center, some breaking free. It's a reminder that the belt's not a static graveyard, but a living, churning region where rocks clash and reshape themselves. Hubble's ability to catch these fleeting moments, collisions, spinning asteroids, plumes on distant moons, shows us a solar system that's anything but predictable. This telescope, orbiting quietly above us, has done more than anyone dreamed. When it launched in 1990, it wasn't just a tool for astronomers. It's a storyteller for anyone who's ever looked at the stars and wondered. Its images of Mars' moons, Jupiter's stars, and Europa's icy jets pull us into a universe that feels both vast and intimate.